Hi students, here in this video we can learn about the next exercise, the next part of the chapter, relations. What is a relation? If you observe the last problem of the previous exercise, we have made 16 subsets from a set containing 4 elements, okay, 4 order pairs, we made 16. So all that subsets are relations. So how is relation is defined? A relation is a subset of Cartesian product. A relation is a subset of a Cartesian product. Now, suppose if A is from 1, 2 and B is from 3, 4, what is the Cartesian product? So 1, 3, 1, 4, 2, 3, 2, 4. And if I take R1 like 1, 3 and 1, 4, this is a relation. And R2, 1, 3 and 2, whatever you want. Whatever you want, if you consider a subset from this basic mother set, then it is a relation. So basically, a relation is a subset of a Cartesian product. Okay. When you write these in a mappings, this is a mapping diagram, Venn diagrams. So when you take 1, 2 here and 3, 4 here, so Cartesian product will be every element should be mapped with every element of the other set. But in relation, what happens? You can map whatever you want. 1, 4, 2, 4. It is also relation 1, 4, 2, 4. Whatever you want, you can map. So according to these mappings, the elements or the sets are named with some particular definitions. Some particular definitions. Those definitions are: one is domain, one is the codomain, and one is the range. And these definitions vary. Definitions will not vary actually. The process of solving the problems using the definitions will vary from this process of doing in Venn diagrams and also the problems of variables, algebraic expressions. Next exercise will have some algebraic expressions where we have to find out the domain, and there the process differs. I'll tell you. See, in this exercise, suppose what is a domain? Domain. And what is a codomain? And what is a range? Okay, if you have two sets, set A, set B. Set A contains 2 elements, set B contains 2 elements. Okay, so domain is the number of elements, or the domain is a set of elements that are being participated in the mapping. Set of elements in A, that are being participated in mapping or in relation, that have been participated in relation 1, 2. Okay, what is codomain? Domain is the number of elements or the set of elements in B, total B, 3, 4. And range, the set of elements in B, the set of elements B which has been participated. So here the domain is 1, 2 because both are participated. Codomain is 3, 4 because all the elements of B, always the second set contains 2 things, codomain and range. First set contains only one, domain. Those are also the elements which are participated in relation. And range is only 4. We do different examples now. Okay, I'll give you. Suppose if A is some 1, 2, B is A, B. So we know A cross B is 1, A, 1, B, 2, A, 2, B. So let us take a relation R1 such that 1, A and 2, A. Okay. So what is domain? Okay. We take one more. C also. 1, C, 2, C. 1 comma A, 1 comma C. What is domain? Domain is the set of elements in A. In A means in the first set that have been participated. Only one. Codomain. Codomain is all the elements of set B. That is A, B, C. And range. Range is the set of elements in P that has been participated. I think all are participated. Okay. Let us do one more example. Please pause this and check this carefully. For the same sets, I take one more relation, R2. 1 comma A, 1 comma B, 1 comma C. Okay. So what is domain? Only one. Codomain, all the elements of B, A, B, C. Range, only the elements here which have been participated. B, C. Now you might have understood. Okay. This is the thing, you can start the exercise. But I told you that while doing domain, sir, why domain we have to take the elements which have been participated here. What is the actual definition of domain? The actual definition of domain is the set of values of x, the set of values of x, or the set of real values for which the function defines. This is a function, or this is a relation actually. Function definition we will get in the next exercise. For which this relation defines. So this relation defines only with 1 in the first element. Is it right? So the set of all elements of A for which the relation defines. So this relation is defined only with 1 in the first element. So that is the domain. And while you consider some algebraic expressions, the domain and range definitions will be little differed, and I'll explain you when we start the next exercise. Okay. Now for this, when you have ordered pairs, this is the only thing that you can remember. Now we start exercise 2.2. Exercise 2.2. So the first question. You are given A as an element of A is a set of elements from 1 to 40, and you are asked to make relation R such that x comma y and 3x minus y equal to 0 and x comma y belongs to A. Now, one more thing I want to tell you. You will be asked to find it in roster form and set builder form, two things. You know, we did this in set standard. This is a set builder form. Set builder form. Set builder form means we don't write all the order pairs. We give one example, add one variable with a definition that explains the whole set. We give one set of variable and a small definition that defines the whole, so small relation that defines the whole relation. And roster form will be writing all the order pairs that is satisfying this. See, what is 3x minus y 0? It means y is equal to 3x. Agree? So suppose if x is 1, y will be 3. If x is 2, y will be 6. If x is 3, y will be 9. If x is 4, y will be 12. If x is 5, y will be 15. We should not take this because you have the set A containing only till 14 and both elements should belong to A. So this 15 does not belong to A. So we stop here. So this is called roster form. Roster form is writing all the possible elements of the sets. Okay, elements, writing all the elements. Set builder form is defining a relation with some variables so that no need to write all the elements of the set. Set builder form and roster form. Now, what is domain here? Domain is the elements from the set A that have participated. What have participated here? 1, 2, 3, 4. Codomain. Codomain will be all the elements of B. Here B is also A. So it is till 14. What is range? Range is the set of elements in B that have been participated. Okay? See, in the next question, we are given a set builder form and you are asked to convert it into a roster form. X and Y both numbers should be taken from natural numbers, and the relation is like this. Let us write it in roster form. X is a number which is less than 4. So we can take 1. When X is 1, Y will be 6. When X is 2, Y will be 7. When X is 3, Y will be 8. Only 3 we have to take. Because X is a number which is less than 4, we are supposed to take. So what is domain here? Domain is 1, 2, 3. Codomain. Codomain is set of natural numbers, all natural numbers. And the range 6, 7, 8. Okay? Right. See, here we are asked to write a relation. Set-Pillar form is given and you are asked to write in roster form. A and B are different sets, and choose A from X from the first set A and Y from the second set B, such that the difference between X and Y is odd. That means I can take 1, 4 because difference is 3, and I can also take 1, 6, difference is 5. I can't take 1, 9 because the difference is 8. It is even. So I can take 2, 4. No. 2, 6, the difference is even. 2, 9 I can take because the difference is odd, 7. And 3, 4 I can take because the difference is 1. 3, 6, yes I can take, the difference is 3. 3, 9 I can't take because the difference is 6. It is even. Now 5, 4 I can take, 5, 6 I can take, but I can't take 5, 9. This is the set. And you can write domain and range also. They didn't ask us to find out domain and range here. That is the thing. See, in this question, we are given two sets like this with a relation, and you are asked to write both in set-builder form and roster form. Set-builder form. Set-builder form. How? Set-builder form is, first let us write all the sets. Before writing set-builder form, let us write in roster form. So it will be easy for us. Roster form. 5, 3. 6 is mapped with 4. 7 is mapped with 5. If you check carefully in set-builder form, how can you write? Are such that if you take the first element, second element is 2 less than the first element. Is it right? So I write like this: x, y such that y is equal to x minus 2. Y is x minus 2 and x is equal to 5, 6, 7. 5, 6, 7. Okay? Or 3 you can write here. Here it is your choice. X is the first 3 consecutive numbers, 3 consecutive natural numbers starting from 5. Like that also you can write. Okay? The 3 numbers which are more than 3 natural numbers more than 4, or 3 natural numbers less than 8, 3 consecutive natural numbers less than 8, 3 consecutive natural numbers more than 4, like that you can write. Okay? Consecutive is very important, guys. Right. This is the set-builder form, this is the roster form. That is what they have asked. Next question. Okay, look here. You are asked to write it in roster form. B is exactly, from this set you have to choose elements A and B. A comma B, so this should be divisible by this. So you can take 1, 1 because 1 is divisible by 1. 1, 2 because 2 is divisible by 1. 1, 3, 3 is divisible by 1. 1, 4, 1, 6 also. In the same way, 2, 4, 4 is divisible by 2. 2, 6 and also 3, 6. That's it. So this should be divisible by this. Now, what is domain? 1, 2, 3 only. What is range? 1, 2, 3, 4, 6. All are range. Okay? I think we have missed something here. When A is divisible by A, you can write 2, 2 also, 3, 3 also, 4, 4 also, 6, 6 also. And your domain also changes 1, 2, 3 also, 4, 6. Okay. So here it is a set is given in set-builder form. and we are asked to convert it into roster form. So let us write, and the x values are given directly. 0 comma it will be 5. We take 1 comma 6, 2 comma 7, 3 comma 8, 4 comma 9, 5 comma 10. So what is the domain? Domain will be 0, 1, 2, 3, 4, 5. All the elements. What is the range? 5, 6, 7, 8, 9, 10 is the range. Okay. See, in the seventh question we are asked to convert this into roster form. X comma x cube are there, and x should be taken from a prime number which is less than 10. Prime number, so we start with 2. When it is 2, it will be 8, 2 cube. 3 is a prime number, 27. Next 5 is a prime number, 125. 6 is not a prime, 7. 7 is a prime number, 343. Suppose a 28. 53. Yes. Next 8 is not a prime, 9 is not a prime. That's it. So this is the set that we can write. In this, did they ask us to find domain and range? No, only roster form. See the 8th question also. A is given number of relations that can be made. A is x, y, z. B is equal to 1, comma 2. So how many relations that we can make from these two elements? So how many relations? Actually, how many Cartesian products we can make? We can make Cartesian products. First of all, number of elements in Cartesian product, A cross B. Number of elements in Cartesian product, A cross B, n of A cross B will be 6. So number of relations means, what is the definition of relation actually? A relation is a subset of Cartesian product, no? So how many subsets that we can make? You can make 2 power 6. That means 64 relations that we can make from the set A to set B. Okay. See, in this question you are given, it is in set-method form. The first element is an integer and second element is an integer, and you have to choose an order pair in such a way that the difference is also an integer. Obviously, when you take the difference of integers, it will be an integer. So, what will be the domain? Domain is an integer, and range is also as an integer, and integer can be denoted with z. Z is integers, guys. This is the denotation of integers. Okay. This is for this video. In the next video, I will explain the brief definitions of the functions, and also domain and ranges you get in that video. All the best, guys.